Hello everyone, it's Mr. Sutherland. So far today, you have done two activities dealing with sequences and an introduction to those. You looked at a TED Talk on the Fibonacci sequence, and you did a worksheet where you were finding missing terms of sequences. And that was just to get your brain working on maybe reminding you what a sequence is. And so today what we're going to focus on here at the beginning of section 9.3 is what is a sequence, using explicit formulas to find terms of a sequence and missing terms, using recursive formulas, and finding limits of sequences and determining whether they converge or diverge. That last bullet point here is probably the newest piece, the piece you haven't done anything with in the past. The other things I believe you've talked about in Algebra 2, but this will hopefully be a good review of those. So first of all, what is a sequence? A sequence is an ordered progression of numbers. So an ordered progression of numbers. And what makes the sequence unique is the domain. So the domain of any sequence, meaning what are you starting with, are your natural numbers. So you start with 1, then 2, then 3, then 4, then 5, and it goes on to wherever the sequence ends, if it does end. If it's an infinite sequence, it keeps going on forever. The range of a sequence are whatever the outputs are of that certain sequence. For the notation, we don't use like the old function notation f of x anymore. For sequences, it's typically used that you use a of n equals, where n represents the term. So like a of 1 would be the first term, second term, third term. So for instance, I think while I do this on the left, it probably would help to look at a sequence and answer some questions or kind of go through these terms as we're going through this sequence on the right here. So let's say you have the sequence that is 3, 5, 7, 9, 11, and continuing on forever. So the domain, what I mean by that is our first term. So the first term is 3, the second term is 5, the third term is 7. So when I talk about notation, I would call 3 a sub 1, 5 a sub 2, 7 a sub 3, because that's the first term, the second term, and the third term. Now when we describe sequences with formulas, there's two main types of formulas we use. There's the recursive formula, which tells you basically how to build the formula. How to build the sequence. How to build it. And then the explicit formula allows you to find any term. This is like our algebraic formula to find any term that we want. So for our example sequence that we're looking at up here, when I do a recursive formula, you always tell the formula, always begins, where does it start? What is the first term? And the first term of our sequence is 3. So when we're building a recursive sequence, we always have where the sequence starts. And then the next thing we're going to have is, what are we going to do? How do we build this sequence? How do I get each new term? Well, in this sequence above, we're going to take each previous term. So the n minus 1 here means the previous term. And we are, it looks like in this sequence, just adding 2 to the previous term. So in the recursive formula, this second step really tells us what to do. So the first step tells us where to start. The second step tells us what to do. The explicit formula would just be the algebraic formula, which we're going to learn how to develop these later. But for this sequence right here is equal to, let's say we would have 2n plus 1. And we're going to talk about how to develop that a little bit later. But if I want to find the first term, I just plug in 1, second term, plug in 2, and so on. So let's look at how we would use each of these. So what I'm going to do with an example is I will do part A, and then what I would recommend is that when we do part B, you pause the video, try it, and then unpause the video to see how you did. So in part A, I want to find the first 4 terms of each sequence. Now A is an explicit formula. So if I want to find the first term, I just plug in 1, 4, n. And so that would be 1 minus 1, which is 0. The second term would be 2 squared minus 2, so 4 minus 2 is 2. The third term would be 3 squared minus 3, which would be 6. And the fourth term would be 4 squared minus 4, which is 12. So my first 4 terms are 0, 2, 6, 12, and that would continue on forever. Now you guys should try B. All right, now assuming that you have tried it, here is what this would look like. The first term would be 2 to the second plus cosine of pi. So 2 to the second is 4. Cosine of pi is negative 1, so 4 plus negative 1 is 3. For the second term, we would have 2 to the third plus cosine of 2 pi. Well, 2 to the third is 8. Cosine of 2 pi is 1, so we have 9. A to the third would be 2 to the fourth plus cosine of 3 pi. So that would be 16 minus 1, which is 15. And then a to the fourth would be 2 to the fifth plus cosine of 4 pi. So that would be 32 plus 1 is 33. So your first 4 terms would be 3, 9, 15, 33, and that would continue on. Now for C, this time we are given a recursive formula. So here is how you use a recursive formula. So we have here that the first term is 5. So that's easy enough. Now the second term. This says I take the previous term, which would be the first term, and I add 8. Well, the previous term was 5, so 5 plus 8 is 13. Now to get the third term, I'm going to take what was the second term now, plus 8. So now I have 13 plus 8 is 21. And then to get the fourth term, I'm going to take the previous term, which was the third term, plus 8. So 21 plus 8 is 29. So I have 5, 13, 21, 29. All right, pause the video and try part D. All right, let's take a look and see how you did. So the first term is negative 1. The second term would be my previous term, which is negative 1 squared plus 1. So that's 2. The third term means I'm going to take the previous term, which is 2, square that plus 1. So that ends up giving me 5. And then the fourth term, I'm going to take 5 and square it plus 1, which gives me 26. So negative 1, 2, 5, and 26. Example 2. Find the fourth term of each sequence. So this is where in part A, having an explicit formula makes these so much easier. Because if I want to find the fourth term, all I have to do is plug in 4 for n. So I have 2 times 3 to the fourth. So I have 2 times 81, which is 162. Now I could have built that sequence out, but there's no need if you have the explicit formula. For B, you have the recursive formula. The only way to get the fourth term with the recursive formula is to build it. So here the first term is 4. The second term, it says I'm going to take 3 times the previous term, which is 4 plus 2. So that's 14. Now I'm going to do 3 times 14 plus 2, which is 44. And then to find the fourth term, I'm going to do 3 times 44 plus 2, which ends up being 134. So if it's a recursive formula, I have to use every previous step. Part C. Now let's take a look at this one. You could try it if you want, pause the video, then come back and see how you did. So with this one, I have the first term is 5. The second term is 7. Now to get the third term, I'm going to take the previous term, which was the second term, minus the term 2 before, which was the first. So I'm really doing 7 minus 5, which is 2. And then to get the fourth term, I'm going to take the previous term, which was the third term, minus 2 before, which was the second term. So I have the third term was 2 minus the second term, which was 7. So I get negative 5. So in this case, we get negative 5. Now, the last thing we want to talk about today is how do you find the limits of sequences. And so the limits of sequence is what happens as n goes to infinity. What happens as I get to the millionth term, the 10 millionth term? Well, two things can happen. Number one, the sequence can converge to a value. We're going to call that value L. So for instance, let's say I had the sequence that went 1, 4/3, 3/2, 8/5, where it's the sequence 2n over n plus 1. Well, I want to know what happens as n goes to infinity. Well, if you remember from rational functions, do you see how those are the same degree? They're both first degree, so the limit was the ratio of the coefficients, 2 over 1. So this sequence should converge to 2. So that means as I go, the terms are going to get closer and closer to 2, but they're never going to pass them. Now, our other option, if it doesn't converge, is we're going to have a sequence that diverges. That means it doesn't go to any value. It goes to infinity or negative infinity or does not exist. So for example here, let's say you had the sequence 1, 7, 13, 19, 26, where that's really if we think about what's going on here, that would be the sequence of 6n minus 5. And what happens as n gets larger, as my terms go, they're going to get bigger and bigger and bigger forever and ever. So this sequence diverges. So let's take a look at an example. Does the sequence converge or diverge? So the first one, we can plug in some numbers and see. If I were to plug in 1, I would have 3 minus 1, which is 2. If I were to plug in 2, I'd have 6 minus 1, which is 5. If I plug in 3, I can see this is a sequence that's going up by 3 every time. So this sequence is going to keep, the numbers are going to keep getting larger and larger and larger without bound. So this sequence diverges. Now let's look at B. If I were to plug in 1, I would get 1 over 3. So I would get a third. If I were to plug in 2, I would get 2 over 6. Which is also a third. Interesting. If I were to plug in 3, I would get 3 over 11. If I were to plug in 4, I would get 4 over 18, so that becomes 2 over 9. And eventually, if I think back to rational functions, my larger degree is in the denominator, so this sequence of numbers is going to get closer and closer to 0. So we say that this sequence converges to 0. Part C. Let's take a look at this one. So if I were to make n 1, well, I would have 1 minus 1 is 0. Anything to the 0 power is 1. So I have 12 times 1 is 12. Now if n were 2, this becomes 6, then 3, then 1.5. And we can see this is getting smaller and smaller, but it's never going to go negative. So we would say this converges to 0 as well. And then the last one, you don't even have to write them out. We can just look at our rules of rational functions. They're the same degree. Therefore, we do the ratio of the coefficients. So this sequence is going to converge to 1. So hopefully now you have an idea of what a sequence is, how to deal with both an explicit and recursive formula, and have begun to explore the ideas of limits of sequence, which we'll spend more time going forward. All right, I'll talk to you soon.